Today we are going to discuss some of the problems on properties of DTFT. First problem, find the DTFT of unit step sequence. It is given x of n is equal to e of n, which is equal to delta of n plus delta of n minus 1 plus delta of n minus 2 plus delta of n minus 3, so on. Or I can write it as summation k is equal to 0 to infinity delta of n minus k. Now put n minus k is equal to m. Then x of n is equal to e of n, which is equal to summation m is equal to n2 minus infinity delta of m. Or e of n is equal to summation m is equal to minus infinity to n delta of m. Since m is a dummy variable, we can write e of n is equal to summation k is equal to minus infinity to n delta of k. By summation property, we have if x of n, if we take DTFT, we get x of e power j ohm, then y of n is equal to summation k is equal to minus infinity to n x of k. If we take DTFT, we get y of e power j ohm, which is equal to x of e power j ohm divided by 1 minus e power minus j ohm plus pi x into e power j0 summation k is equal to minus infinity to infinity delta of ohm minus 2 pi into k. And already we know that delta of n, if I take DTFT, I will get 1. Using summation property, we have e of n is equal to summation k is equal to minus infinity to n delta of k. If I take DTFT, 1 divided by 1 minus e power minus j ohm plus pi into summation k is equal to minus infinity to infinity delta of ohm minus 2 pi k. Then for assuming for one cycle e of n, if I take DTFT, I will get 1 divided by 1 minus e power minus j ohm plus pi into summation k is equal to minus infinity to infinity delta of ohm. Next problem, show that the DTFT of the sequence x e power j ohm naught n is given by x of e power j ohm is equal to summation k is equal to minus infinity to infinity 2 pi delta into ohm minus ohm naught plus 2 pi k. We know that if I take DTFT of 1, I will get summation k is equal to minus infinity to infinity 2 pi delta into O plus 2 pi k. Using frequency shift property, we get e power j ohm naught n. If we take DTFT, we get k is equal to minus infinity to infinity 2 pi delta ohm minus ohm naught plus 2 pi k. Using the appropriate properties, find the DTFT of the given signal. It is given x of n is equal to half to the power n into e of n minus 2. X of n is equal to half to the power n into e of n minus 2. We can write it as x of n is equal to half to the power 2 into half to the power n minus 2 into e of n minus 2. And we know that half to the power n into e of n, if I take DTFT, I will get 1 divided by 1 minus half into e power minus j o. And using time shift property, we get half to the power n minus 2 into e of n minus 2. If I take DTFT, we get e power minus j 2 ohm into 1 divided by 1 minus half into e power minus j o. And using linearity property, we get half square into half to the power n minus 2 into e of n minus 2. If we take DTFT, we get half square into e power minus j 2 ohm into 1 divided by 1 minus half into e power minus j o. Therefore, x of n is equal to half to the power n into e of n minus 2. If I take DTFT, I will get 1 by 4 e power minus j 2 ohm into 1 divided by 1 minus half e power minus j o. Therefore, x of e power j o is equal to 1 by 4 into e power minus j 2o divided by 1 minus half into e power minus jo. Using appropriate properties, find the DTFT of the signal x of n is equal to sin pi by 4n into 1 by 4 to the power n into e of n minus 1. It is given x of n is equal to sin pi by 4 into n into 1 by 4 to the power n into e of n minus 1, which is equal to e power j pi by 4n minus e power minus j pi by 4n divided by 2j into 1 by 4 into 1 by 4 to the power n minus 1 into e of n minus 1. Therefore, x of n is equal to 1 by 8j into e power j pi by 4 into n 1 by 4 to the power n minus 1 into e of n minus 1 minus e power minus j pi by 4n into 1 by 4 to the power n minus 1 into e of n minus 1. And we know that 1 by 4 to the power n into e of n, if I take DTFT, I'll get 1 divided by 1 minus 1 by 4 e power minus jo. Using time shift property, we get 1 by 4 to the power n minus 1 into e of n minus 1. By taking DTFT, we get e power minus jo 1 divided by 1 minus 1 by 4 e power minus jo, which is equal to 1 divided by e power jo minus 1 by 4. And using frequency shift property, we get e power j 5 e power j pi by 4 n into 1 by 4 to the power n minus 1 into e of n minus 1. By taking DTFT, we get 1 divided by e power j o minus pi by 4 minus 1 by 4. Then using linearity property, we get 1 by 8j e power j pi by 4 into n into 1 by 4 to the power n minus 1 into e of n minus 1. If we take DTFT, we'll get 1 by 8j into 1 divided by e power j into o minus pi by 4 minus 1 by 4. Similarly, 1 by 8j e power minus j pi by 4 into n into 1 by 4 to the power n minus 1 into u of n minus 1. If we take DTFT, we get 1 by 8j into 1 divided by e power j into ohm plus pi by 4 minus 1 by 4. Therefore, x of e power j ohm is equal to 1 divided by 8j into 1 divided by e power j into ohm minus pi by 4 minus 1 by 4 minus 1 divided by e power j ohm plus pi by 4 minus 1 by 4. Next problem, let x of n be a sequence given by x of n is equal to 3, 0, 1, minus 2, minus 3, 4, 1, 0, minus 1, with DTFT x of e power j ohm. Evaluate the following functions of x of e power j ohm without computing x of e power j ohm. First one is x of e power j0, second one is x of e power j pi, third one is integration minus pi to pi x of e power j ohm into d ohm, fourth one is integration minus pi to pi mod of x of e power j ohm whole square into d ohm, and last one is minus pi to pi mod of differentiation of x of e power j ohm divided by d ohm square into d ohm. Let us solve one by one, and we know that x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. So first one is x of e power j0. So by putting ohm is equal to 0 in the above equation, we get summation n is equal to minus infinity to infinity x of n, which is equal to x of minus 3 plus x of minus 2 plus x of minus 1 plus x of 0 plus x of 1 plus x of 2 plus x of 3 plus x of 4 plus x of 5. So by putting the given values 3 plus 0 plus 1 minus 2 minus 3 plus 4 plus 1 plus 0 minus 1. So therefore x of e power j0 is equal to 3. Second one, x of e power j pi is equal to summation n is equal to minus infinity to infinity x of n into e power minus j pi n. which is equal to summation n is equal to minus infinity to infinity x of n into minus 1 to the power n, which is equal to minus 3 plus 0 minus 1 minus 2 plus 3 plus 4 minus 1 plus 0 plus 1. Therefore, x of e power j pi is equal to 1. Then third one, x of n is equal to 1 divided by 2 pi integration minus pi to pi x of e power j ohm into e power j ohm n into do. By putting n is equal to 0 in the given equation, we get x of 0 is equal to 1 divided by 2 pi integration minus pi to pi x of e power j ohm into do. Therefore, integration minus pi to pi x of e power j ohm into d ohm is equal to 2 pi into x of 0, which is equal to the value of x of 0 is minus 2, that is 2 pi into minus 2, which is equal to minus 4 pi. And fourth one, from Swath's theorem, we have summation n is equal to minus infinity to infinity mod of x of n square is equal to 1 divided by 2 pi integration minus pi to pi mod of x of e power j ohm square into do. Therefore, integration minus pi to pi mod of x of e power j ohm square into do is equal to 2 pi into integration n is equal to minus infinity to infinity mod of x of n square, which is equal to 2 pi into 9 plus 0 plus 1 plus 4 plus 9 plus 16 plus 1 plus 0 plus 1, which is equal to 82 pi. And the last one, once again we have to use Parseval's relation. From Parseval's relation, we have summation n is equal to minus infinity to infinity mod of x of n square is equal to 1 divided by 2 pi integration minus pi to pi mod of x of e power j ohm whole square into do. Now, using frequency differentiation property, summation n is equal to minus infinity to infinity mod of minus jn into x of n square is equal to 1 divided by 2 pi integration minus pi to pi mod of differentiation of x of e power j ohm divided by do square into do, or integration minus pi to pi mod of differentiation of e power j ohm divided by do square is equal to 2 pi into summation n is equal to minus infinity to infinity mod of n into x of n square, which is equal to 2 pi into 81 plus 0 plus 1 plus 0 plus 9 plus 64 plus 9 plus 0 plus 25, which is equal to 378 pi. Next problem, find the DTFT of the signal x of n is equal to minus 1 to the power n into a to the power n into a of n mod a is less than 1, using frequency shifting property. It is given x of n is equal to minus 1 to the power n into a to the power n into a of n with mod a is less than 1, which is equal to e power j n pi into a power n into u of n. And we know that a to the power n into u of n, if I take DTFT, I'll get 1 divided by 1 minus a into e power minus j o. And using frequency shifting property, e power j n pi into a power n into e of n, if we take DTFT, we get 1 divided by 1 minus a into e power minus j ohm minus pi, which is equal to 1 divided by 1 plus a into e power minus j ohm. Therefore, minus 1 to the power n into a to the power n into u of n, if we take DTFT, we get 1 divided by 1 plus a into e power minus j ohm. Find the time domain signal corresponding to the following DTFT. It is given x of e power j ohm equal to cos square ohm. We know that xn is equal to 1 divided by 2 pi integration minus pi to pi x of e power j ohm into e power j ohm n into d ohm. Therefore, x of n is equal to 1 divided by 2 pi minus pi cos square of ohm into e power j ohm n into d ohm, which is equal to 1 divided by 2 pi integration minus pi to pi e power j ohm plus e power minus j ohm divided by 2 whole square to e power j ohm n into d ohm, which is equal to 1 divided by 8 pi integration minus pi to pi e power j2 ohm plus e power minus j2 ohm plus 2 into e power j ohm n into d ohm, which is equal to 1 divided by 8 pi integration minus pi to pi e power j2 ohm into e power j ohm n into do plus integration minus pi to pi e power minus j2 ohm into e power j ohm n into do plus integration minus pi to pi e power 2 into e power j ohm n into do. Then using time shift property, we get x of n is equal to 1 by 4 into delta of n plus 2 plus delta of n minus 2 plus 2 into delta of n.